In 2025, the landscape of space exploration will transform in ways that merge past dreams with emerging realities, unveiling breathtaking missions, revolutionary technologies, and discoveries that push humanity to the threshold of a new cosmic age. From renewed efforts on the moon to the hunt for alien life on distant exoplanets, each milestone underscores how profoundly our sense of identity and possibility is about to shift. This text offers a deep dive into 10 remarkable developments anticipated in 2025, weaving them into a continuous narrative that reveals the interconnected nature of our ongoing quest to expand human presence into the cosmos, harness off-world resources, and uncover the secrets of life and matter in the universe. Along the way, each paragraph will delve into the nuances of upcoming missions, the scientific objectives behind them, and the larger societal and philosophical implications of this unfolding saga. Humanity's renewed focus on the moon marks one of the most tangible shifts we will witness in 2025. Although the Apollo missions left an indelible imprint on our collective memory, only now are we truly preparing to install lasting infrastructures on our lunar neighbor. Spearheading this new wave are two pivotal robotic landers. One of these is Intuitive Machines' Athena lander, destined for the moon's south pole around March 6, 2025. Its mission aims to locate and analyze water ice deposits concealed in the eternally dark craters scattered across the polar regions. Scientists believe that water on the moon, if confirmed and extractable, could become a pillar of future space exploration, supporting extended human stays and powering rocket propellant production for voyages deeper into the solar system. The second mission, Firefly Aerospace's Blue Ghost Mission 1, will deploy an array of cutting-edge instruments to sample lunar regolith and gather data about its composition, thermal properties, and the footprints left by billions of years of meteorite impacts. Despite the moon's appearance as a static gray desert, every grain of dust has a story to tell, a record of cosmic forces etched into the dust. By decoding these fragments, we not only unravel the moon's history, but also refine our knowledge of Earth's own past, since both bodies have shared many cosmic events throughout the solar system's history. These missions herald the start of NASA's broader Artemis program, which outlines a path to an enduring moon base. Artemis envisions habitats, laboratories, and resource extraction facilities that convert the moon from a silent wanderer to a vibrant frontier. Over the long term, if these initiatives meet their goals, the public may witness an era when stepping onto the moon becomes routine, part of an ever-growing Earth-Moon economy that trains explorers for further leaps, particularly the long-desired journey to Mars. NASA, 2024, Blue Ghost Mission 1, Firefly Aerospace, 2024. As our efforts extend beyond Earth's satellite, asteroids demand renewed attention. Long regarded as cosmic debris, these primordial rocks turn out to be treasure troves of both science and potential economic value. Kamawalawa, a quasi-satellite of Earth with a peculiar orbit, is the focal point of China's Tianwen-2 mission in 2025, Chinese National Space Administration, 2024. This mission will attempt to rendezvous with Kamawalawa to determine its composition and clarify whether it might be a fragment of our own moon or a captured body from elsewhere in the solar system. Because asteroids formed at a time when the sun and planets were still coalescing, their chemistry likely retains signatures of the solar system's early building blocks. Such details can illuminate how water and organic molecules might have been ferried to the primordial Earth, aiding in the emergence of life. Concurrently, the private sector eyes these rocky bodies for commercial potential. Astroforge Brock 2, slated for February 27, 2025, explores a near-Earth asteroid believed to harbor valuable metals like platinum and nickel. Astroforge, 2024. If successful, this mission could catalyze an entire off-world mining industry that sees asteroids as a source of raw materials for construction, fuel generation, and other advanced applications. Harvesting resources outside Earth can mitigate planetary environmental impacts and ignite a space-based economy that underpins future habitat building. The synergy between scientific curiosity and commercial impetus exemplifies how the frontier of asteroid research weaves together origin stories and groundbreaking resource exploitation. Planetary Resources, 2024. While the solar system is flush with challenges and rewards, the most captivating question remains: is Earth unique in hosting life, or do myriad other worlds also foster biology? Our exoplanet discoveries have ballooned in recent years, offering glimpses of possibly habitable environments around distant stars. In 2025, NASA's Pandora project will intensify this search, focusing on 20 exoplanetary systems encompassing nearly 40 worlds. By using spectroscopic techniques, scientists will parse the starlight passing through exoplanet atmospheres, identifying the molecular fingerprints of water vapor, oxygen, methane, or other potential biosignatures. If even one exoplanet demonstrates a combination of gases incompatible with non-biological processes, the cosmic silence is effectively broken. NASA Exoplanet Science Institute, 2024. Meanwhile, the Vera C. Rubin Observatory in Chile is scanning the night sky more thoroughly than any previous survey, capturing billions of objects in an effort to address the mysteries of dark matter distribution and possibly detect new exoplanets through microlensing events. Should these studies yield persuasive signals of life or complexities in the dark matter framework, the entire discipline of astrophysics could be reshaped overnight, leading to new theories that challenge fundamental concepts of biology and cosmology. Rubin Observatory, 2024, European Space Agency, 2024. Turning inward, 2025 will also be a milestone in human spaceflight and living habitats beyond Earth. The commercial sphere is stepping up with expanded ambitions, starting with Vast Haven 1, the first commercial space station built explicitly for long-term habitation, Vast Aerospace, 2024. While the International Space Station forged an international collaboration model, Haven 1 signals a shift toward more specialized, possibly privately run stations. Entrepreneurs envision these habitats as multi-purpose venues, research labs for pharmaceutical breakthroughs, tourist destinations for wealthy enthusiasts, and microgravity facilities for manufacturing exotic materials that are costly or impossible to replicate under Earth's gravity. Complementing this is SpaceX's Fram-2 mission, which aims to take crewed flights into polar orbits. Such a trajectory can examine rarely seen regions of Earth and test the psychological and physical demands of traveling outside standard low Earth orbit inclinations. SpaceX, 2024. Each success forms a foundation for bolder undertakings, eventually leading to a new generation of explorers who might regard Earth as home, but see space as a normal extension of their environment, akin to crossing an ocean. Progress in rocket technology also stands at the heart of these expansions. A prime illustration is the SpaceX Starship refueling demonstration. Conventional rocket missions are constrained by how much fuel they can carry at liftoff. Beyond that limit, additional voyages become too logistically cumbersome. By demonstrating the feasibility of in-orbit refueling, engineers will enable spacecraft to depart Earth's gravity well with minimal load, then obtain the fuel they need from specialized tankers already waiting in orbit. SpaceX, 2024. This cuts mission costs dramatically, eliminates the mass penalty, and opens the door to multi-leg journeys. One can foresee a scenario where starships carry cargo to the moon, top off, continue to Mars, refuel again using Martian resources, and return, forming a cyclical transport chain. In effect, in-orbit refueling rewrites the constraints that have historically bound rocket flight, setting the stage for an interplanetary economy. At the center of the solar system lies the Sun, an incandescent nuclear furnace influencing every aspect of planetary environments. The upcoming Solar Dynamics Explorer, SDE, will unravel new details about solar flares, coronal mass ejections, and the interplay of magnetic arcs that sculpt solar plasma. Solar events can have outsized impacts on Earth. Large flares can disrupt radio transmissions, damage satellites, or overload electrical grids. By collecting exquisite high-resolution data, the SDE fosters improved solar weather forecasting, letting us protect vital infrastructure and plan for possible severe events. NASA, 2024. Additionally, advanced knowledge of solar dynamics might spur innovative solar-based energy solutions, from efficient solar panels to advanced space-driven power generation. On top of that, unraveling the sun's secrets has philosophical resonance. In many ancient cultures, the Sun. In the solar system's outer realms, icebound moons orbit the gas giants, each potentially hosting subsurface oceans. One of the most enthralling developments in 2025 is the refined data from NASA's Europa Clipper. Already en route to Jupiter, this probe will begin delivering detailed assessments of Europa's ice thickness, surface geology, and chemical composition. If it locates convincing indications of water beneath the crust, perhaps warmed by tidal flexing, the notion of life in a hidden ocean becomes more than idle speculation. NASA, 2024. Similar interest extends to Ganymede and Saturn's Enceladus, both featuring conditions that might support microbial ecosystems. If any of these worlds yield unequivocal evidence of living organisms, be it microbes or something more complex, human culture and science would undergo a seismic shift, compelling us to reconsider the uniqueness of Earth-based biology, possibly spurring an entire generation of missions dedicated to exploring these newly revealed biospheres. Looking beyond these near-term solar system adventures, the observation of gravitational waves remains a cutting-edge frontier that merges astronomy with fundamental physics. In 2025, upgraded detectors such as LIGO, Virgo, and CAGRA will achieve heightened sensitivity, granting scientists the ability to detect more frequent or fainter signals from cosmic cataclysms like merging black holes or colliding neutron stars. LIGO Scientific Collaboration, 2024. Each detection acts as a small shockwave in our understanding of space-time. It confirms predicted phenomena, refines our knowledge about how mass and energy interplay, and reveals hidden corners of the cosmos, from the earliest stellar remnants to surprisingly large black hole mergers. Soon to follow is the space-based Laser Interferometer Space Antenna, LISA, projected to float in Earth's orbit around the Sun and detect lower-frequency gravitational waves from supermassive black holes. While LISA's final deployment is scheduled beyond 2025, the technology's stepping stones will accelerate in that year, marking an era when listening to the cosmos can be as productive as watching it. Another frontier concerns quantum leaps in how we communicate, not just on Earth, but also with spacecraft or stations hundreds of thousands, or even millions, of kilometers away. Building on successes like China's Mischius satellite, quantum communication initiatives in 2025 might lay the groundwork for secure, high-bandwidth data links leveraging quantum entanglement or advanced encryption protocols. Quantum Communication Research, 2024. The potential is staggering. Imagine a scenario in which Earth-Lunar or Earth-Martian communications become almost unhackable, reliant on quantum key distribution that can detect any intrusion attempt. The ramifications for finance, global governance, and even personal privacy are profound. Meanwhile, quantum networking might open new forms of data throughput, bridging the challenges of latency in interplanetary travel. Although instantaneous quantum teleportation of classical information remains impossible by known physics, quantum entanglement can still revolutionize how signals are verified and secured. One of the most visionary developments set for 2025 is a readiness to chase interstellar objects, forging new inroads into understanding material from outside our solar system. Recent encounters with Oumuamua in 2017 and Comet 2I/Borisov in 2019 tease the possibility that foreign cosmic travelers periodically enter our domain. The Interstellar Voyager initiative addresses exactly that scenario, preparing a specialized probe on standby for swift deployment to any newly detected interstellar body. Interstellar Probe Initiative, 2024. If successful, it would be the first attempt to directly analyze matter formed around a star perhaps tens or hundreds of light years away, capturing data that might rewrite astrobiology, stellar chemistry, and planetary formation models. Even a sliver of dust from such an object, studied under microscopes on Earth, could uncover isotopic ratios or mineral compositions entirely unlike our solar system's norms, hinting at the diversity of processes sculpting planets throughout the galaxy. Collectively, these convergent paths, lunar bases, asteroid resource extraction, exoplanet atmosphere analysis, gravitational wave astronomy, quantum communication, and more, reveal 2025 as a year of synergy. Each discovery builds upon the next, weaving scientific progress, economic possibility, and philosophical wonder into a single tapestry. Where once each mission or field seemed compartmentalized, we now see how a leap in rocket refueling methods might enable exoplanet intercept missions, or how improved quantum encryption fosters safer transmissions of vital scientific data gleaned from far-flung telescopes. Technological leaps do not exist in isolation but feed each other, stimulating further leaps in the chain of innovation. Humanity stands, therefore, on the cusp of transformation. For centuries, we watched the skies, telling stories of gods and monsters inhabiting worlds we could never reach. This mental boundary frayed in the 20th century, replaced by robotic explorers and human footprints on the moon. Now, in the decade of the 2020s, culminating around 2025, we see an accelerated push, not simply visiting space, but living there, not simply glimpsing distant exoplanets, but analyzing their composition, not simply using satellites, but forging quantum links that promise a revolution in communications. Our solar system, once an unreachable horizon, might begin feeling like a backyard orchard, ripe with resources, scientific revelations, and perhaps, in places like Europa or Enceladus, the stirrings of unknown life forms. Within these breakthroughs loom ethical and existential challenges. The exploitation of asteroid resources, for instance, raises questions about ownership, environmental stewardship, even in space, and the potential for economic inequality if certain entities gain exclusive access to off-world wealth. The possibility of discovering extraterrestrial life, microbial or otherwise, demands deliberations about planetary protection, potential biosafety hazards, and the moral significance of encountering an alien ecosystem. Meanwhile, quantum communication and advanced gravitational wave research bring us deeper into realms that test our scientific knowledge, forcing us to question whether our definitions of energy, matter, and space-time are flexible enough to encompass new phenomena. At a more intimate level, the presence of commercial space stations and the notion of prospective off-world births in the near future redefines social constructs, from citizenship to healthcare and even the sense of home. If a child is born on the moon or on a station near Earth, how will that shape their culture, language, or sense of belonging? And if they visit Earth, which has far stronger gravity, how do they adapt physically and psychologically? These are no longer the domain of far-fetched science fiction. As missions become routine, such scenarios transition from fictional speculation to pressing policy considerations. Beyond the practical, the ongoing wave of breakthroughs fosters a renaissance for the human imagination. Already, novels, films, and games have begun weaving plausible narratives around these missions, shaping the public perception of cosmic exploration. People worldwide may watch rocket landings or rover deployments via live streams, forging a sense of collective participation in cosmic events. A teenager in a developing country can follow an interstellar object chase with the same engagement as a seasoned scientist in a state-of-the-art lab. This democratization of wonder has the power to unify cultures and spark collaborative solutions to Earth's pressing issues, fueled by the shared recognition that we inhabit just one small planet in an enormous cosmic tapestry. In short, 2025 stands as a crossroads. The 10 space-related breakthroughs outlined here, fresh lunar missions, asteroid rendezvous, exoplanet life detection attempts, expanded human spaceflight, advanced rocket refueling, deeper solar scrutiny, explorations of ice-covered worlds, gravitational wave expansions, quantum communications, and the pursuit of interstellar visitors, illustrate a year of interwoven leaps. Each success or failure will guide subsequent steps, reinforcing the synergy between new technologies, new questions, and new frontiers. Bound together, these milestones form a narrative arc propelling humanity from Earthbound watchers to solar system pioneers, possibly culminating in a future of genuine interstellar exploration. Despite how large or audacious these goals seem, they are grounded in the combined endeavors of national agencies, private enterprises, scientific collaborations, and the persistent curiosity driving human culture. The line between everyday technology and space technology blurs, as the same quantum breakthroughs or AI-driven data analyses feed both a mission's success and consumer products on Earth. That synergy is precisely why the quest for cosmic discovery resonates far beyond specialized labs. It influences economic models. Moving beyond our solar system, exoplanets multiply the possibilities exponentially. In recent decades, astronomers have identified thousands of these distant worlds, ranging from scorching hot Jupiters to rocky super-Earths and watery ocean planets. Each setting could spawn a distinctive lineage of humanity, shaped by local gravitational fields, atmospheric compositions, and stellar radiation patterns. Proxima Centauri b, TRAPPIST-1e, and Kepler 452b stand out for their relative promise in terms of temperature, possible water presence, or Earth-like qualities. Yet each environment introduces novel challenges: stellar flares, tidal locking, extreme orbital periods, or alien geochemistry. For example, while TRAPPIST-1e resides in its star's habitable zone, the system's ultracool dwarf star might bathe the planet in radiation different from sunlight on Earth, altering what plants or photosynthetic processes could emerge and how human biology might respond. If humanity were to colonize many exoplanets, each environment would shape a different strand of evolution. After thousands of years, the differences could be so profound that a human from Kepler 442b might appear drastically at odds with a human from Earth or Proxima Centauri b. Genetic drift, selective pressures, and possibly deliberate genetic engineering would all accelerate this divergence, raising questions about the eventual unity or fracturing of the human species across galactic distances. Establishing birth on a far exoplanet inevitably blends scientific ambition with deep ethical considerations. The complexities of ensuring children survive in an alien environment would require robust oversight and moral dialogue. Would these colonies remain tethered to Earth's governance? Or might they develop as fully autonomous societies with separate social norms and legal frameworks? As such communities expand, they might also pioneer radical changes in governance, reflecting the singular demands of living countless light years away from human origins. Exoplanetary living likely depends on advanced terraforming or at least partial environment control. Over time, if natural selection alone is too slow or uncertain, humans might rely on genetic modification, adding traits to help them cope with local conditions. Improved radiation resistance, specialized respiratory organs, or higher tolerance for exotic atmospheric chemistry. Each step forward redefines the boundary between natural evolution and deliberate engineering, further questioning how we classify the term human. Long before Earth-based evolution can catch up, interstellar colonists might proactively alter their offspring's genes to match exoplanet demands. This planned adaptation merges biology and technology into a single process, effectively orchestrating the next phase of humanity's cosmic saga. While that approach could be extremely beneficial, controversies surrounding designer humans raise potential social rifts or unforeseen consequences. The line between adaptive necessity and manipulative hubris may remain blurred. In exoplanet colonies, existential threats could become the norm. Alien skies, unfamiliar day-night cycles, or constant storms might induce heightened anxiety or a longing for Earth's relative stability. Cultures that emerge may celebrate communal rituals to cope with isolation and to foster a deep-rooted sense of place. Artwork, storytelling, and spiritual traditions might revolve around local cosmic phenomena, forging a new cosmic identity that replaces Earth nostalgia with an authentic exoplanet bond. As exoplanetary communities evolve, the physical distance from Earth, possibly tens or hundreds of light years, could limit or end real-time communication. Future humankind may find itself split into multiple enclaves, each forging its own destiny under different stars. If contact remains sporadic, knowledge exchange might slow, or we might see brief pulses of cultural reunions whenever starships or advanced communication methods link these far-flung societies. Over epochs, these expansions might weave a tapestry of human civilization across the galaxy, each node bearing the uniqueness of its planetary cradle. As the missions of 2025 unfold, we can expect that each success quickly transitions from miraculous to mundane. Lunar water extraction, once sensational, may soon be taken for granted as a standard resource. Asteroid metals that have resided untouched for millennia might become a routine part of industry supply chains. We might find ourselves measuring time not just by seasons or fiscal quarters, but by intervals between rocket launches, with new module additions to orbital stations as common an event as the opening of a building downtown. And if exoplanet data suggests even a hint of extraterrestrial biology, the public dialogue could shift drastically, focusing on the moral and practical implications of contacting or eventually visiting these remote ecosystems. By 2025's end, the fabric of our universe may appear more intricate than any of us imagined a decade earlier. The cosmic wonders unveiled, like the shifting dunes of Mars, the hidden seas of Europa, the cryptic signals from possible alien atmospheres, or the ephemeral gravitational wave echoes of star collisions, will remind us how small Earth is in the grand design, yet how remarkable it is that we can comprehend, to an ever-growing degree, the cosmos around us. Each discovered detail stands as a testament to our collective drive to decode nature's script, to learn from the distant past, and to shape a future that outpaces the limitations once believed unbreakable. In the broadest sense, these 10 mind-blowing space developments of 2025 illustrate a continuum of scientific enterprise that straddles discovery, commercial potential, cultural impact, and existential yearning. We approach a horizon where the cosmos is not an abstract domain, but a living extension of human society, where the routines of an orbital station or the chatter of an asteroid mining outpost become part of daily life. The year 2025 is not an endpoint, but a pivot, pointing us toward new leaps in the decade to come, as each question answered births a handful of deeper mysteries. Whether these mysteries revolve around the architecture of space-time, the chemistry of life, or the edges of our moral frameworks, they beckon us forward. They promise that, in forging alliances across earthly divides and harnessing the best aspects of human curiosity and ingenuity, we can carve out a destiny worthy of our cosmic potential. In that spirit, these expansions into space also serve as a humbling reminder of responsibility. If we do not reflect on sustainability, both ecological on Earth and in terms of planetary protection for worlds we touch, our cosmic footprint may replicate Earth's environmental missteps on a far grander scale. If we do not address potential inequalities in the distribution of space-derived resources, we risk a future where only a select few control the spoils of the solar system, intensifying earthly divides. And if we do not engage in open, global collaborations, we diminish the synergy that has propelled us so far. The success of 2025's bold ventures rests as much on wise social governance as on scientific breakthroughs or rocket engines. The blueprint for balancing exploration with stewardship will matter profoundly because the cosmic environment, though vast, is also delicate in ways we are just beginning to grasp. Therefore, 2025 not only becomes a year of technological ascension, but also of moral reckoning. A time to decide how we handle discoveries that could reframe our view of life, resources that might alter global economies, and expansions of humanity that could change our very essence as a species. The next steps in space exploration are not a footnote in humanity's story. They are part of its epic center, bridging how we handle today's issues with the destiny that tomorrow's children will inherit. The 10 developments enumerated here form a tapestry of knowledge and aspiration, each mission or discovery braided with the promise of forging a more profound comprehension of ourselves. In closing, the wave of cosmic revelations in 2025 stands as a testament to humanity's natural inclination to question, dare, and explore. Our spacecraft will land on new surfaces, our sensors will peer into distant star systems, and our minds will wrestle with the grand wonder of existence. We will find footprints of ancient collisions in gravitational wave signals, glimpses of potential living atmospheres around exoplanets, and tangible resources that transform how we perceive cosmic emptiness. More than ever, the boundaries that once defined our understanding blur, replaced by a sense of awe at the vast expanse that awaits. Through the synergy of public ambitions, private entrepreneurship, and global scientific collaboration, the year 2025 emerges as a portal to an era where space is not an edge but a center, not an unreachable dream, but a tangible domain where each mission reaffirms our capacity to grow beyond Earth's cradle.